Thank you very much. My name is Sajid Awan. I'm Director of Product Management in VRNI at VMware. Joined VMware as part of the Veriflow acquisition, and I'm responsible for integration of Veriflow into the VRNI product. So today I'm going to describe to you the main value proposition as well as show you a demo of the product. So Veriflow is focused on intent-based verification. And as you know, intent is a very important component for a business where how they use the technology to meet their business intent. So when you design, build, or operate your network, you need to keep the intent in mind. And how do you verify that intent? That's where Veriflow comes into play. So Veriflow collects information from various network components, and it focuses on layer 1 through 4 of the infrastructure, and it builds a model. Now, when you combine Veriflow with Verni, it has the ability to go all the way from layer 1 to layer 7, as well as bring application awareness, flow awareness into the picture. So Veriflow is able to take the information, especially the data plane information, and that includes routing table, forwarding tables, access lists, firewall rules, and so on, from routers, switches, load balancers, firewalls, cloud, and including Verni, it will also be able to take that information from virtual infrastructure and build an end-to-end model. And with that model, it understands exactly how the network behaves, what the network will do to any type of traffic that arrives. So basically, with Verni, you get a top-down view of applications and how the packet flows are going through the network. And with Veriflow, you get the bottoms-up view, exactly how the network is ready to behave when those packets arrive. And when you combine that, you get the true end-to-end picture of the overlay and underlay infrastructure. So with that, Veriflow uses formal verification to build a model and then analyzes the model for the intents. And that's how we know whether the network is doing exactly what you want it to do. In this slide, there are some use cases, typical use cases, how several of our customers are using this product, and it's applicable to many industries. The use cases start all the way from visualization. A lot of customers use it to build as-built diagrams, or as part of the change planning, they need those that visualization. So with Veriflow and Verni combined, you get that end-to-end overlay and underlay visualization on one pane of glass. Then several customers use the search capability for troubleshooting purposes, whether you are trying to troubleshoot an application problem or a security problem, whether you're trying to troubleshoot reachability or segmentation issues, you can use this product for a network-wide troubleshooting platform. The next area is detecting problems. So troubleshooting comes into play when you already know a problem, you want to figure out what the root cause of the problem is. But the system also helps you detect problems. That's where intent verification comes into play. A lot of the intents are auto-configured. They are inferred based upon what the network is. However, network users can also define their own business intent. So an example of business intent would be, imagine a bank that has 5,000 ATM machines, and they want all these ATMs to talk to the core banking system, but they don't want anybody else to talk to the ATM. So that's a reachability and a segmentation intent in that description. And you can configure this, or you can auto-infer that as well if you are integrated with an ATM controller. And based upon that, the system will always tell you whether that intent is being met or not. Because every time you make a change, there is a risk that this intent is no longer being met. So you want to be verifying the network on a continuous basis. Next area is dynamic diff. So with our system, you will be able to see how things have changed, how there is a drift in the network. And every time there is somebody touching the network, there is a risk that in a large organization, some applications will be affected. And in large organization, many customers may be touching the network. So you always want to know what is the difference, let's say today versus yesterday. You can also share that information with auditors for compliance purposes if they want to know what has changed in the network over past few months. And the last area is pre-flight verification, or a lot of customers call that what-if scenarios. So we support that for access list changes. Access list changes are the most common changes in any network. So once you deploy the network, a lot of requests start to come in. Hey, I want to deploy a new application, so let's open access for that. Or I want to block some users, let's restrict access for that. Before you make a change in the real network, you want to know what will be the impact of a firewall rule change so that you are not messing up the stuff that is already working. And that's where this pre-flight scenario comes into play. We allow you to build a pre-flight model of the network with access list changes so you can predict ahead of time what the impact would be. So with that, feel free to ask any questions. I'm going to show you several of these examples during the demo. So you can see a network diagram on your screen. So imagine you have deployed Veriflow. It collects information from the network. And the first thing you get is this dynamic map of the network. And it's divided into various regions. And as you zoom in, you get more details about the network. For example, IP addresses, port information, MAC addresses, device information, and so on. And this information is being updated dynamically from the network, and it's very useful for the purpose of visualization as well as planning. But not only I know the network, I also know what's in the network in detail. So I'm going to perform a search. In this case, my search query says, tell me all my Cisco devices in New York which are running version 15.2 of the software. So imagine you receive an advisory from Cisco that says all devices that are running 15.2, they need to be upgraded. Now you quickly want to find out where are these devices in the network. And even if you get that information from an inventory management system, you still want to know where in the network is the impact of upgrading these devices. So with this one quick query, you get this answer. And the search language is very powerful. You can get the information sliced and diced in many different ways. And then as you look at these devices, you get a lot more details that it's a layer 3 switch, it's management IP, and so on, what VLANs are configured on it. And here is the version 15.2 of the operating system. You get information about interfaces as well. What is the MAC address and MTU and VLANs on that interface, any errors, whether it's a trunk or not. So all of this information is searchable, and then you can write intents on that, which I will show you later on. So not only I have a diagram of the network and I know what's in the network, I'm going to perform a path search to see how things are going from point A to point B. So in the interest of time, I'm just gonna copy and paste this search here. And what it is saying is, how do I go from a certain IP address to another IP address? And imagine there is a security engineer that walks up to a network engineer's office and says, this destination is under attack, can you block it? So the network engineer has to quickly find out exactly how the hacker is able to get to these destinations. And in a large network, this can take time. And the engineers are trying to do it manually, so they may make a mistake. They may find 2 paths when actually there are 20 paths. So quickly they get the answer, and now they can go through the details and say exactly how this traffic is flowing. And you can see on the right-hand side, we have a detailed path inspector. This is like traceroute on steroids. So quickly you can expand this and see exactly how the traffic starts, what is the signature of the packet, how it goes through interface by interface, device by device. And I can see that I have this firewall in front of the data center that should have blocked this traffic. So why this firewall did not block the traffic? I can look at the access list rule, which is allowing this traffic. So you can go down to that precise level of information, which will help you troubleshoot. So now you can fix this access list to resolve the concern of security engineer. And I'm going to just change this search a little bit and give you the same example from the perspective of an application engineer. So let's say an application engineer walks into a network engineer's office and says, this application was working yesterday, but today it's broken. Can you fix it? So again, application engineer can quickly do that search and find out that, oh, there is a firewall which is blocking this traffic. And again, they can go through the details of a packet inspector and say, exactly which rule in the firewall is blocking this traffic. And if there are multiple block points along the way, it will highlight all of them. So this is really important troubleshooting mechanism. Now we talked about problem detection. That comes from intents. So we have a very powerful intent library in which you can configure several intents. There are different categories of intents that can be configured. The intents that have been configured, they show up on the left-hand side. And I'll give you an example. Let's say I have a segmentation intent where I don't want guest Wi-Fi to talk to the primary data center. Guest Wi-Fi can go to the internet, but they should not be able to reach my primary data center. So I would configure the intent like this, that guest Wi-Fi, and so I give it a name. Then I define my source and destination segments, and these are the ones that need to be isolated. I can also define exception traffic, that traffic should be blocked except for this kind of traffic. And the moment I save this intent, the system will continuously be checking for this intent, and every time this intent fails, it will tell me that in this snapshot, this intent is failing. So all the intents that are failing, they show up here on the Explorer page in the Events tab. And you can see that there are many intents that have been checked. Several of these were auto-inferred. For example, there should be no loops in the network. And whenever there is a loop, it's highlighted. You don't need to configure this intent. We automatically check for loops. Same thing, another example I will show you is a reachability intent for HSRP traffic. So in this case, our system has identified that core 1 and core 2 are HSRP pairs. They should be redundant. And it has also identified that this firewall can reach certain subnets through core 1, but not through core 2. And today, everything is fine because traffic is going through core 1 because core 1 is up and running. But the moment core 1 goes down, or sometimes it's intentionally brought down for maintenance, and core 2 takes over, this subnet will not be available. This service will be down. So that's the predictive nature of our solution. It predicts ahead of time that how a failure would impact the traffic. And then you can go deeper. You can select these flows and look at the path inspector, and you can say, okay, why is this firewall not able to reach that subnet? So here is the routing table of the firewall, and the problem area is highlighted in yellow. So you can see 10.2.0 has 2 paths, 10.2.20 has 2 paths, but 10.2.10 only has 1 path. And that's mainly because firewall is not learning that from OSPF, from core 2. So it takes you to the root cause of the problem. It's like finding needle in the haystack. It's telling you that the problem is with routing, not with an access list. So it's that level of precision that helps you fix the problem.
If I can interject right now, is in the background example, you've got GCP and AWS showing there. And my question is, are you able to use the Veriflow tool to illuminate problems that may exist inside that infrastructure, such as these things are open and accessible from the internet. These things have, the normal problems that we tend to hear about in the public press around breaches and problems. And it was usually, this thing was open, this thing was accessible, it should have been closed in some way. Can Veriflow be used to help illuminate and enlighten that within an infrastructure?
Absolutely, yes. And as we integrate with Verni, you will get even more capabilities. But right now, what I'm showing you, there is already this capability of collecting information from public cloud, building a model, and then checking for those things. And several of those things we check automatically, like which subnets or which instances are open to the internet and where there are no rules defined. All those things are checked automatically. And whether there is an address mismatch or address conflict between public network and private network. All those things are also checked. Okay, so I was giving you a few examples of the intent. Let me give you one more example. This is the intent that we had configured earlier, which is that guest Wi-Fi should not be able to reach primary data center. In this example, the guest Wi-Fi is able to reach the primary data center. So I can quickly see how it is reaching, exactly what kind of packets are able to go through. And again, I have a firewall that should have stopped this flow. So I can go down to that firewall and see exactly which rule in that firewall is allowing this traffic to go through. Here is the access list somebody has put in the network without my knowledge, and that's what is allowing this traffic. So now I'm able to detect problems. The next step I'm going to show you is how we fix it in the model before you actually fix it in the real network. Many large firewalls may have 80,000 rules, and the engineer who put those rules has probably left the company. Nobody wants to touch those rules because something else may break. So in this case, now I'm going to fix this in the model using pre-flight verification. So in pre-flight verification, I'm going to select the snapshot that I was working with, and I'm going to look for that firewall. It's a Palo Alto firewall, so it's a very long config you can see on the right-hand side. So I'm going to press Control F and search for that guest Wi-Fi rule. Here is that rule that I want to change. I will press Edit. I can just delete the whole thing, or I can change action from allow to deny. And as I hit save, the system is going to create a new model. And in the interest of time, I've already built that new model, and it shows up as a new snapshot right here. This is the pre-flight snapshot which has been built. And in this pre-flight snapshot, all the information is coming from the real network, but with this one access list change that I have made. And now you can see the segmentation problem where guest Wi-Fi was able to reach primary data center, that segmentation problem is no longer there. Okay. So that is how pre-flight works. I'll give you another very important use case, and then I'll close with that. And that is a dynamic diff. So diff is a capability where you can see what has changed between any two snapshots. And as I said, in a large network, many engineers are touching the network. A lot of times people don't know that their changes are conflicting with each other. So with this diff capability, you can see that there are topology changes in the network. There are device configuration changes, like new access lists have been added or some have been removed. There are state changes. There are intent changes. So an example is that the last pre-flight snapshot that I built, that intent change, you can see that previously the intent was failing and now the intent is passing. I'll give you one very specific example which is useful. So in the dynamic state changes, here are 25 layer 3 routes that have changed. And I pick any one of them, and I can see that in this device, this specific default route has changed. It's previously going to a certain next hop, and now it's going to a different next hop. Now, if the users in that area are complaining about performance, this could be the reason. And as you know, how difficult it is to pinpoint performance problems, because due to this change, their traffic may be going through a longer path or higher latency path. So these are the examples of use cases and how the system helps. And as I said, as Veriflow gets integrated with VRNI, all of this capability will be extended, so you can see the virtual and physical infrastructure, the overlays and underlays together, and get the value from the platform. There are several dashboards that are available. You can use these as NOC dashboards. On top, there is a summary of intents that are passing and failing, network statistics, some reports for compliance purposes, some health scores. Similarly, this system has very powerful REST APIs that can be used to integrate with any external system, which could be part of your overall closed loop network management system. We can integrate with ServiceNow to create trouble tickets. We can integrate with HPNA so that anytime there is a device added, HPNA knows about it, and it can trigger a new collection in Veriflow and a new verification. So all of those are examples, but not limited to that.